This video is for Chapter 6, Section 2, and it is all about the properties of parallelograms. One of the key things to address here is that the properties of parallelograms are not the definition. These are additional pieces of information that we have learned about parallelograms that don't necessarily exist in other shapes. Some shapes have these properties, but these are the ones that are true for parallelograms. And that means they are true for all parallelograms, which we have learned means that rectangles, rhombuses, and squares will all have the same properties. Before we begin looking at these properties, I want us to look at this shape here, where I have a parallelogram marked with two pairs of parallel sides, and I have marked the alternate interior angles that are congruent, as well as the diagonal down the middle there congruent to itself. From previous material, we have learned that this has two triangles that are congruent by angle side angle. Parallelogram is one of the few quadrilaterals that can be split with a diagonal, and it cuts it into two congruent triangles. Now those triangles are what is going to allow us to produce the properties of parallelograms. There will be 5 things and we'll get started. I described the 5 things about parallelograms using my hand, where the thumb, which is the first of 5 fingers, is a little different. It's the definition. The definition of a parallelogram: both pairs of opposite sides are congruent. So the first conclusion that can be made, if LUKE is a parallelogram, we can say that LU is parallel to EK. And we can conclude that UK is parallel to LE. I use my thumb to represent this one because this is not one of the properties, this is the definition. One of the 5 major things we need to know, but it's somehow different than the next 4. So here we go, first property. Now, key, we have to know it's a parallelogram first. And if we do, here's one of the conclusions. Opposite sides of a parallelogram are always congruent. So, if it's a parallelogram, LUK is a parallelogram, then I can make the conclusion that LU is congruent to EK. This is different than parallel. They are congruent to each other. And UK is congruent to LE. This is property number 1. Opposite sides of a parallelogram are congruent. Now, we're not going into the proof, but it has to do with the fact that these two triangles are exactly the same. So the corresponding parts of those triangles are the same, this side and that side. Opposite sides of a parallelogram are congruent. Property number 2, kind of makes some logical sense here. Opposite angles of a parallelogram are congruent. Again, stemming from the same thing. These triangles are congruent, so those angles are congruent. Corresponding parts are congruent. So, opposite angles of a parallelogram are congruent. If MICH is a parallelogram, we can add these markings. Notice that the markings in the picture, those are the ones you add. You have to be told it's a parallelogram, then you add these markings. Opposite angles of a parallelogram are congruent. M is congruent to C, I is congruent to H. So these are not the markings we start with, but rather this is what we add when we hear it's a parallelogram. So we have the definition on our thumb, and we have 2 properties so far. Opposite sides are congruent, opposite angles are congruent. Let's move to property number 3. Consecutive angles of a parallelogram are supplementary. Now, this comes from the fact that the top line and the bottom line are parallel, and we still have the congruent marks here, but what we're saying now is that if this is 80 degrees, then this one has to be 100. Consecutive, 1, then the next one. Some people say adjacent, but they're not really adjacent. They're consecutive in order. But that means 80, 100. Consecutive angles means, well, that one has to be 80. And then this one has to be 100. This works out so that all of the consecutive angles are supplementary. Same side interior angles are supplementary because of parallel lines. Same side interior angles are supplementary, parallel lines. 180 plus another 180 over here equals 360. That's the total for a quadrilateral. This is the only shape where, because the opposite angles are congruent, it turns out consecutive angles are supplementary. So, if MICH again is a parallelogram, we can conclude M is supplementary to I, and then I is supplementary to C, and C is supplementary to H, and H is supplementary to M. Property number 3. Final property of parallelograms. The diagonals of a parallelogram bisect each other. If we were to draw both diagonals into this picture, they will end up intersecting each other at their midpoints. Point A is the midpoint of both. So we would mark A to T the same as A to C. We would mark A to E the same as A to S. Be careful. We're saying they bisect each other. That doesn't mean they create 4 congruent parts. Just TC is being cut in half into 2 congruent parts. SE is being cut in half into 2 congruent parts. If STEC is a parallelogram, then TC and SE bisect each other. That is the 5th property. Definition: both pairs of opposite sides parallel. Property 1, opposite angles of the parallelogram are congruent. Sorry, opposite sides of the parallelogram are congruent. Property 2, opposite angles of the parallelogram are congruent. Property 3, consecutive angles are supplementary. Property 4, the diagonals bisect each other. Those are the 5 important things that you will use to solve problems involving parallelograms. We will get into examples of solving in class, and we will get into the proofs or sort of why these things work more in class. That's it for this video, Chapter 6, Section 2.